Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials, and my name is Tutor Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, I'll be taking us PBB 111, a topic called lichen and what mycorrhiza. Okay, this is a subtopic under kingdom fungi. I've treated the first part of kingdom fungi. After taking lichen and mycorrhiza, I'll be taking the divisions of kingdom fungi. Before I do that, let us do justice to these two terms on the board, lichen and what? Mycorrhiza. Now, lichen is an association between a microbiota. This microbiota is actually the fungus. It is an association between a microbiota called the fungus and the phycobiota called what? The algae. Alright? Which means that we can say that lichen is a feeding association between a fungus and what? And algae. Fungus is microbiomes. You know, fungus they have what? Mycelia. Then algae they are called what? Phycobiomes. Take note of that. Now, the work of the fungus is to provide shelter and accommodation for the algae. It provides accommodation and what? Shelter. Now, owing to the fact that algae are photosynthetic, they're autotrophic because they have pigment for what? Photosynthesis. Now, they provide food and nutrient for the fungus. You can see it is what? A symbiotic association. Yeah, please. The association that occurs between a fungus and algae called lichen is what? Symbiotic or what? Mutualistic. I gain from you, you gain from me. It is what? A mutualistic feeding association, not parasitic. Now, we have different places lichen occurs. Some are found in, when lichen occurs in soil, wood, and rocks. Alright? Oh, good. When lichen occurs in soil, wood, and rocks, such lichen is called what? A crustose. Alright? Crustose. When a lichen occurs in soil, wood, and rocks, it is called what? Crustose. Take note of that. A good example of such organism is the Onchroletia tartaria. Alright? That is Onchroletia tartaria possesses what? Crustose as what? A type of what? Lichen. Now, when a lichen now occur as an outgrowth, when it occurs as an outgrowth from the substrates, you know the substrate is what they feed on. When it occurs as an outgrowth from the substrates, such is called what? Fructose. Okay, fructicose rather. Fructicose, alright? When it occurs as an outgrowth from the substrate, such lichen is called what? Fructicose. This fructicose is possessed by an organism called um, Diponia uh, rangiformis. Rangiformis, alright? Diponia rangiformis possesses what? Fructicose as a type of what? Lichen association. But if this lichen appear to be what? Membranous, if it appear to be membranous or foliaceous, that is a form of leaf-like. When it's membranous or foliaceous or leaf-like, such is called what? Foliose. Foliose is possessed by an organism called Xanthonia peretta. Is it Peretina or what? You check the spelling out, check it out, okay? So these are the various types of what? Lichens that we have and the organisms that are what? Involved. Take note of that. So outgrowth is fructicose, soil, wood, rocks, crustose, membranous or foliaceous or leaf-like folios. Take note of that, please. What's what is lichen used for? You know, lichen, they can be found in rock, that is wood, that the economic importance of what? Lichen. Some are found in dead wood, and they help in the breaking down of dead wood to become what? Nutrient, okay? Which means that they act as what? Decomposers. Fungus in general act as what? Decomposers, because they're what? Saprophytic. They help in breaking down dead and decaying organic matters to become what? Nutrient or manure, okay? And lichen is also used to produce what? Litmus paper. You know, litmus paper is used as what? As an acid or basic what? Indicator. It is used as what? Indicator. That is litmus paper. So that is all about what? Lichen. That is all about lichen. The next one is what? A mycorrhiza. Mycorrhiza. Mycorrhiza is an association between the roots of higher plants and a fungus. Mycorrhiza is an association between the roots of higher plants and what? Fungus. Okay, there are two types of mycorrhizas. Mycorrhiza. There are two types. We have the ectomycorrhiza. We have the ectomycorrhiza and we have the endomycorrhiza. So these are the two types. Hope it's recording. Good, thank God. Now, so these are the two types of mycorrhizas. We have the ectomycorrhiza and we have the endomycorrhiza. Now, in the ectomycorrhiza, the fungus is just found on the surface of the roots. Right? The fungus is found on the surface of the roots. That is, it does not penetrate the roots. Take note of that. Examples of plants that possess ectomycorrhiza with fungus are the oak, cactus, the pine, that is Pinus species, and now have the beech, Fagus species. Now, oak, pine, beech are examples of plants that possess what? An ectomycorrhiza association with what? Fungus. Take note of that. Then, as for the endomycorrhiza, the fungus penetrates the roots of what? The plant. It penetrates the roots of the plant, and therefore, since the fungus is present, it helps the roots of the higher plants to obtain what? Phosphorus from tropical soil. Alright, this endomycorrhiza occurs in what? Tropical plants. Okay, now since the fungus is there, it helps the root of these fungus trees, tropical plants, to absorb phosphorus from tropical soil, from the soil. Please, that is all about what? The endomycorrhiza. It is this endomycorrhiza that now leads to what is called vesicular arbuscular mycorrhiza. Right, it is this endomycorrhiza that leads to what? Vesicular arbuscular mycorrhiza. That is VAM. VAM. Now, what is now the meaning of vesicular arbuscular mycorrhiza? Let us check what it is. The vesicular arbuscular mycorrhiza is an interaction that occurs between bryophytes, pteridophytes, angiosperms, and gymnosperms. with what? A fungus. Vesicular arbuscular mycorrhiza is what? An interaction that occurs between bryophytes, which are non-vascular seedless plants. These are vascular seedless plants. I said it occurs between bryophytes, pteridophytes, angiosperms, and gymnosperms with what? Fungus. Now that is the meaning of what? Vesicular arbuscular what? Mycorrhiza. Now, since we've established that fact already, now what is the mechanism behind this V? Don't forget we are discussing VAM, okay? Vesicular arbuscular what? Mycorrhiza. Now this fungus that is present in this association will penetrate the plasma lemma. And that word for plasma lemma I told us is what? Cell membrane. Alright, okay, okay, no. You know, the hyphae branches present in fungus is called what? Haustoria. And haustoria is the roots of what? Parasitic plants. The root of parasitic saprophyte is called what? Haustoria. Now this haustoria penetrates the plasma lemma, which is cell membrane, to form what is called arbuscula. This arbuscula means what? I think tiny tree. Let me add this. This arbuscula means what? Tiny tree. As soon as the haustoria or storium of fungus penetrate the plasma lemma called cell membrane, it forms what is called what? Arbuscula, called what? Tiny trees. Alongside, it also produce what? Vesicles. These are what? Storage bodies. That's why it is called what? Vesicular arbuscular what? Mycorrhiza. Because as soon as the haustoria of the fungus penetrate the plasma lemma, it forms what is called arbuscula, which are tiny trees, vesicles, which are what? Storage bodies. Please, the mass of tiny bodies is called arbuscles. Mass of tiny bodies is called what? Arbuscles. Take note of that. Please, it is your haustoria that penetrate the plasma lemma that produce, since we are using IA as plural, that produce arbuscula and what? Vesicles. Please take note of that. It is very what? Important, okay? I think that is all about mycorrhiza and what? Lichen. Please take note of everything that has been said. So we are going to look at the various divisions of kingdom fungi. We've said everything about lichen and mycorrhiza. So the next one is what? The different divisions of kingdom fungi. Where is that board wiper? This one is bad. The various divisions of kingdom fungi. All right. Now we have 5 divisions of kingdom fungi. All of these 5 divisions, one of them is known as what? The primitive one, called what? Chytridiomycota. It is primitive because it has features that are not present in the terrestrial what? Fungi. Let's go into it. We have division Chytridiomycota. Alright, division Chytridiomycota. And these guys, they are non-septate. I told you if you don't use the word non-septate, you can also say aseptate. If you don't say aseptate, you can say cynocytic hyphae. Alright, cynocytic, aseptate, non-septate are the same. Right, they mean the same thing. It means that the hyphae are not divided by cross walls. It means that the hyphae are not divided. Now, what are the features of this? Okay, the division is called what? Tritidal mycota, but the organisms found there are called chytrids. All right, chytrids. Okay, so sometimes people call it chytrids. Chytrids. Whichever. But this is what the spelling. Now, what are I said these guys are what? Primitive fungi because they have features that terrestrial fungi do not have, which means that these organisms, they are mostly what? Aquatic. They are mostly aquatic, which means that they are found in water bodies. They are found in water bodies, or they live in water. Now, I told us that the cell wall of a fungus is made up of what? Chitin. The cell wall of a fungus is made up of what? Chitin. But most of the members, or most of the chytrids, they have what? Cellulose in their cell wall. You can see that they've turned the characteristic up and down. Now, cellulose is present in normal green plants. All right, the cell wall of green plants possess what? Cellulose. But these guys, they are non-chlorophyllous. They do not have chlorophyll, but they have cellulose in their cell wall. Normal fungus has chitin in its cell wall, but these guys, they have cellulose in their cell wall. A few also possess what? Chitin in their cell wall. Then apart from that, they have spores that are motile called what? Zoospores. Motile spores. They have motile that are what? They have spores that are what? Motile spores. Alright? That is, the spores can what? Locomote. These organisms also have what? Flagellum. Let me use flagella. Now, I told us that the hyphae of the chytrids, or the chytrids, is non-septate, but in the roots it is what? Septate. In the roots it is what? Septate. And it is in the root you have what? This flagella occurring there. This flagella occur in the root. So these are the distinguishing feature of what? The chytrids. They are called primitive fungi because they have features that normal terrestrial fungi do not have. Take note of that. It is very important. The most commonly known member in this division, Tritidal mycota, is the Allomyces macrogynous, which is what? The water mold. All right, Allomyces macrogynous is what? A water mold, and it is what? A chytrid, a chytrid. Take note of that. Now, let us discuss mode of reproduction. Mode of what? Reproduction. Mode of reproduction. Now, let me bring out some terms here. We have excuse me. Now, the fusion of haploid nuclei will produce a what? A zygote. And of course, you agree with me that this zygote is usually what? Diploid. Now, these zygotes, it will germinate. As soon as it germinates, it produces the sporotallus. Alright? The germination of these zygotes will produce what? The sporotallus. Now, this sporotallus that has been produced or that has germinated from these zygotes will now develop a thin mitosporangia or mitosporangium. This sporotallus produced will develop thin mitosporangium and thick thick myosporangium. Look at it. Zygotes germinate to produce what? The sporothallus. This sporothallus will develop the thin mitosporangia. It is thin, while this one is what? Thick. It is what? Thick. Now, this mitosporangium produced will release what is called okay, it will release the zoospores. Zoospores called what? The motile. Okay, before now, yes, something just occurred to me. Before the fusion to form zygotes, okay, the male gametangium, the male gametangium will produce what is called cyrenin. Now, this cyrenin is a a chemo a chemotactic substance, right? This cyrenin produced by the female is what? A chemotactic substance. It attracts the gametes of the male organism for what? Fertilization. As soon as fertilization occurs, it produces what? Zygote. Which means that for fertilization to occur, the female must produce what? A cyrenin, which will now attract the gametes of the male organism to produce what? Zygote. So this zygote will be like this. So as soon as these zoospores, excuse me, as soon as these zoospores are released from the thin mitosporangium, it will develop into the sporotallus. The sporotallus. Now this sporotallus is known as is diploid actually. This is diploid entity. It is diploid entity and it is recessive. Again, exactly. I just remembered. Tetrads, they show true alternation of our generation. Tetrads, they show true alternation of our generation in which the sporotallus is recessive stage while the gametotallus is what? The dominant stage. Now, the zoospores will give rise to what? The sporotallus, okay? Now, this one has been produced, which is what? The recessive stage of these guys. Now, the myosporangium produce what? The myospore. The myospore, which is found in the myosporangium, will produce what? Haploid filamentous gametotallus stage. All right, now which means that these two guys, they are filamentous, please. Sporotallus is filamentous, as well as what? The gametotallus, they are filamentous. So that is how the life cycle goes. Please take note of that. It is very important. Now for this haploid filamentous gametotallus to be produced, it would undergo what? Meiosis to produce what? This gametotallus, which is what? The dominant phase. So that is all about the Chytridiomycota. All right, so please take note of that. Thin mitosporangium and thick myosporangium. Myosporangium has the myospore, which produce what? The gametophytes or gametotallus stage. Then the mitosporangium produce zoospores, who will now lead to what? Sporotallus. It is diploid. This one is what? Haploid. Take note of that. So let's take the next division. Let's take division Zygomycota. Zygomycota. That's Gmycota. Chytridiomycota. You sing like the acronym is actually ZAB. ZAB. Then you have C as the last one. So you have two zygomycota. Zygomycota, these are called the conjugating. These are called the conjugating with fungi because they undergo a special type of reproduction called what? Conjugation. Okay. Now the members here are actually the black bread mold. The black bread mold is called what? Rhizopus stolonifer. They now have the bread mold. You now have what? The bread mold. The bread mold is called what? Mucormycete. You can see. So which means that the black bread mold and the bread mold constitutes, or they are found in division Zygomycota. Division Zygomycota. These guys, they are non-septate. They are non-what? Septate, which means that their hyphae are not what? Divided. Now, okay, is there another thing I'm yet? Okay, definitely they are what? Saprophytic. They are saprophytic in form. They are saprophytic in form. And they store carbohydrates as what? Glycogen, normally. Glycogen. And their cell wall is made up of what? Chitin. Chitin, okay? So that is for that. So reproduction. What kind of reproduction do they undergo? Sexual type of reproduction called what? Conjugation. They undergo a sexual type of reproduction called what? Conjugation. Now during this process, two different hyphae will come together to form what? To form the gametangium. Alright, I said during conjugation, two different hyphae will come together to form what? The gametangium. Now this gametangium, we have the male gametangium and the female gametangium. When they fuse together, they'll form what? Multi-nucleated zygotes. They form what? Multi-nucleated what? Zygote. Now, this zygote is actually what? Diploid, alright? It has a lot of nucleus in it. Now, this zygote has an outer coat called zygopore. Alright, it has an outer coat called what? Zygopore. Okay, there's H, sorry. Zygopore. Now this zygopore we rupture. As soon as it ruptures, the zygote inside the zygopore would be released to, as soon as it's released, it germinates to produce what? A mycelia. Alright? Mycelia is actually the whitish or grayish structure that somehow produces what? The hyphae. Good. As soon as this mycelia is produced, this mycelia produced will now result in production of what? Hyphae. Okay, and from hyphae, that's what it produces what? Sporangiophore. And this sporangiophore houses the sporangium. Now this sporangium is what? Cone shaped. Look at it. The zygotes, okay, fine, okay, but let me put it like this. As soon as this zygote is produced, it is housed in a wall called what? The zygopore. Now this zygopore, when it ruptures, it produces what? The mycelia. This mycelia will develop what? The hyphae. The hyphae. Now it is this mycelia that produces what? This sporangiophore. Alright? It is this mycelia that also produces what? This hyphae. Now this on this sporangiophore, you have what? The sporangium. It is this sporangium that you have the spores found. The spores are found in the sporangium. In the sporangium, the spores are found in the sporangium. Now, as soon as these spores fall on a fertile gland, they produce what? A new mycelia. That is how the chain continues. Now, this is what? The sexual reproduction, okay? Sexual reproduction. While the asexual, there's what? Formation is through spore formation. Spore formation, okay? Which means that the spores in the sporangium will now fall to the soil to produce what? A mycelia. A mycelia, okay? Which means that sexual reproduction is through conjugation, all right, while asexual is through what? Spore formation. So please, good examples. Okay, I've given us the two commonly known members, which are the black bread mold, which is a Rhizopus solifer, and the bread mold called what? Mucormycete. Good. I just remembered something now. Good. These zygotes formed act as the sporophytic stage. Sporophytic stage. And you now have what? The gametophytic stage. Of course, this one is recessive, and this one is what? Dominant. Take note of that. But I forgot to drop something called what? Pilobolus. Pilobolus is dung dwelling ascomycetes. Dung dwelling ascomycetes, meaning that when you have spores present in vegetative cells, when you have spores present in what? A vegetative cell, vegetative cells. Now, once an animal swallows or eats this cell, the spores present then begin to germinate in the intestine. Of what? The animal. As soon as the animal defecates, definitely dung is what? Produced. You now see that these ascomycetes, they've already what? Germinated inside the dung, so they are called what? Pilobolus what? Ascomycete. That is dung dwelling ascomycete. Okay, that is for that. The third one is ascomycota. Let's take ascomycota. The ascomycota are called what? The sac fungi. Ascomycota. These are called what? The sac fungi. And these guys, they are what? They are septates. Because their hyphae are divided by cross walls. Okay, they are divided by cross walls. Now, what are the features of this ascomycota? Now, some ascomycetes produce hyphae. That is, the hyphae producing ascomycetes. Examples are the Ascolobus crenulatus. We have Neurospora cytophila. Now, these two ascomycetes, they produce hyphae, right? They are hyphae producing what? Ascomycetes. Now, there are some that do not produce hyphae. They are called what? Non-hyphae producing ascomycetes. Right? These non-hyphae producing ascomycetes are called what? Brewers or baker's yeast. Alright, take note of that. Examples are Saccharomyces Saccharomyces cerevisiae, Saccharomyces cerevisiae, and a type of yeast called Schizosaccharomyces octopudus, Schizosaccharomyces octopudus, which is a type of what? Yeast. We now have what? The riboflavin source. That is riboflavin what? Fungus that does not produce what? Hyphae. It is called Erythrithium what? Ashby. Alright. These do not produce opis. It's a sin. Let me check, please. Excuse me. Okay, yes, which means I can see right on that one here. Now, Erythrithium ashby, I said it's what? The riboflavin source. And of course, you know the other name for vitamin B2 is what? Riboflavin, okay? Now, you now have the food yeast called Turula utilis. So these are examples of ascomycetes that do not produce what? Hyphae. Please, they will tell you pick the odd one out. Pick the odd one out. They will give you these ones. We have 1, 2, 3, 4. Then the fifth option will be what? One of these. So this will be the odd one because these ones they produce hyphae, but these ones do not produce hyphae. All right. Take note of that. Take note of that. Now, these organisms, okay, I'll wrap up this one. These ascomycetes, their ascopore are found. Okay, the ascopore is housed by the ascus. All right. All right. By the what? Ascus. Ascus is singular. Why asci is what? Plural. Now, this ascopore is this correct? It should be this correct spelling now. Okay, no. Okay, they produce ascocap rather. Ascocap is the fruiting body. Ascocap is what? The fruiting body. Ascocap is what? The fruiting body of the ascomyces. And these asci are housed by. Oh, no. Ascocap is the fruiting body. Alright, you also have what is called ascopores, okay? The ascopores house the asci. Alright, please don't take one for the other. The fruiting body is called the ascocap. Then ascopore, which are actually spores, they are the one housing what the asci or ascus. Take note of that. Now, we have different types of ascocaps. We have 3 types of ascocaps. We have the paritecium. Okay, that's apotecium, peritecium, and the clistothecium. So these are the 3 types of what? Ascocaps. These are the 3 types of what? Ascocaps. Now, this apothecium, which is the first type of ascocap, it is open. It looks like what? Wine glass. It looks like what? Wine glass, and it is open. It has what? A curved structure at the top, and this curved structure is called what? Hymenium. Hymenium is that curved structure that is found at the top of this what? Apothecium. The function of this hymenium inside the ascocap is to produce paraphysis. Feces. And the function of this paraphysis is to enhance spore dispersal. Alright? The function of this paraphysis is to what? Enhance spore dispersal. Take note of that. This perithecium is also open. It's an open ascocap. It also possesses what? The hymenium. You can see that, which means the first two, they are open and they possess what? The hymenium, while the clistothecium, they are closed and they do not possess what? Do not possess hymenium. Alright? They do not possess what? Hymenium. Take note of that. These ascomycetes also produce what? Conidia. Alright, conidia is housed by a spore called conidiospore. Alright, conidiospore is a special type of hyphae that houses what? Spore. A hyphae or a type of hyphae that houses spore is called what? A conidiospore. And this conidiospores houses or suspend or holds the conidia. Okay, the deuteromycota, which are the fungi imperfecta or imperfect fungi, they also produce what? Conidia. All right, the deuteromycota, they also produce what? Conidia. Now sometimes scientists take deuteromycota for the words as ascomycota because they both possess what? Conidia. Good. They are the deuteromycota and is known as what? Or division deuteromycota. Why the organisms are called what? Deuteromycetes. They are called imperfect fungi because they do not undergo a sexual mode of what? Reproduction. All of the various divisions that we have, it is only the deuteromycetes. Look at the word here, please. Deuteromycetes. It is only deuteromycetes that do not undergo what? Sexual mode of reproduction. Then asexual mode of reproduction is by what? Fragmentation. Is by what? Fragmentation. Take note of that. It is very, very important. Now, I said they do not undergo sexual mode of reproduction, hence they are called what? Fungi imperfecta or imperfect fungi, and they also produce what? Conidia, just as what? The ascomycetes. A good example of a deuteromycete is what is called the Candida albicans. The Candida albicans. Candida albicans. It is this Candida albicans that causes what? Candidiasis in animals.